Hello, everyone. Today we'll talk about availability zones, why they even exist, how to use it, when to use it, and basically how to deploy them with an automation. So who we are? We are OpenInfra, and thank you all for coming. It's very important because community is heart of every project, and it's very important that we are all there and we are such great community, and we are driving progress together. And I am very humbled to be part of this community. But eventually, my name is Dmitriy, as I was already represented. I am OpenStack-Ansible project team leader. I'm a member of technical committee and domain leader of cloud engineering and Cleura. What is Cleura, you will ask? Well, Cleura is the European cloud. Its headquarters is in Sweden. We provide public cloud, compliant cloud, private cloud. We also certified with ISO standards for information security, for resilience, environmental management, and quality assurance. At the moment of speaking, in public cloud, we manage 6 regions, 60 terabytes of RAM, 4,500 CPU cores, almost 5 petabytes of storage. And it's only block storage, it doesn't account object storage actually. So why we actually started looking at availability zones? Well, it's a really good question. First of all, it was a matter of improving resiliency and redundancy. Eventually, the goal was that whenever we do maintenance window, customers in one availability zone should never experience issues when maintenance is completed in another availability zone, regardless it's a compute upgrade or network node upgrade. There should be no effect on availability zones. Next is to use isolated file rooms or even data centers. Eventually, in our case, we had to separate between data centers at least 10 kilometers in distance between each other. It's not only for fire protection, but it's also an ISO certificate requirement that some distance must be between data centers in case of, I don't know, some accidents, earthquakes, or whatever. Then with the solution, we had to continue providing common APIs for managing resources. Under that I mean that toolings like OpenStack Client, Terraform, Ansible collections should resume working because interoperability is a thing, and we truly believe that a user, when comes from one cloud provider to another cloud provider, should feel like a home and don't expect any inconveniences with that. And yeah, of course, customer requests. Customer was using AWS, then they come to OpenStack and they want to see what they used to, which is availability zones, so they ask us, and we can't really reject customers, right? We need to make customers happy. So basically with this we are going to the topic of how are we going to design availability zones. And it's quite a topic on itself because it really depends on company requirements and what trade-offs they are ready to make and what basically services they are providing, if it's public cloud, if it's private cloud. What we came up with is having 3 availability zones because 3 is a good number for quorums. And talking about quorums, it's not only infrastructure clusters, it's also basically client deployments that will happen in this region because they also need some kind of redundancy and splitting cluster between availability zones. In each availability zone, we have member of Cleura cluster, member of RabbitMQ, API backends for OpenStack services, independent set of hypervisors and net nodes, and of course storage. But eventually, some of resources can be shared across AZ. You can stretch, for example, storage nodes. And of course, you can share tenant networks as well. It might be important, I mean, there is another way of workaround in this. For example, instead of sharing tenant networks, you can implement weekend as a service. But from other side, it's not that convenient because in case of failover, volatility will go down anyway. But let's talk about recovery and failure a bit later. So basically, from this picture, we already can make some assumptions on where to use and where not to use ability zones. So it can help you to share resources. So, for example, if I don't know, you want to create the same tenant network VMs in AZ1 and AZ2 and AZ3 and make them a cluster, and they all work nicely. And in case one AZ goes fully down, you still your cluster is still running. It still has floating AP and yeah. But from other side, distance between regions does really matter, and you can stretch resources only if traffic is cheap and it is reliable. Because, for example, for storage, if you have 20 kilometers of distance between availability zones, it already will affect latency. So, if you want high throughput, low latency storage, probably you shouldn't stretch storage into availability zones and make independent storage nodes. But again, it really depends on your requirements. And actually, what ability zones won't do, they won't help you to improve control plane resilience. Because basically, in case of some issue with relative queue or with ability cluster, like failed migration between versions for database, it will affect APIs and availability zones. And basically, not all services also support scheduling processes, and simple example is Octavia. So you can say Octavia spawning load balancer in AZ1 and AZ2. You can just set default ability zone for load balancer. So we came to redundancy. As you might see, the same picture changed a bit. So we can see that all incoming traffic is going to HA proxy. And HA proxy sends the traffic to only local API endpoints. First of all, it's made this way. It's made this way because you want to limit cross-AZ traffic because it might be expensive and it's high latency anyway. And the second, because you will get a faster response basically, so it's no reason to move it anywhere else. Yeah. But what will happen if one service fails in some availability zones? Basically, HA proxy will pass traffic to another availability zone, and service still be reachable, and you will see, and clients will see how interactions actually. But what if availability zone full goes down? Basically, you will see impact, and customers also will. But level of impact also depends on if you stretch storage at that node. Because if you stretch storage, you can do disaster recovery in another ability zone. You have capacity there. And yes, you will need to do some manual hacks to make instances from AZ1 spawn on AZ2. But it's still possible. And if you stretch also tenant networks in case of failure, routers will fail over and they will start in different ability zones. So things should work perfectly. But again, it depends on if you share the resources or not. But instances that are running in the queue, they will be unavailable anyway, and there will be impact on like isolated. And yeah, for API services, it will be just fine. But yeah. So, there is two-way headlines on the previous picture. All requests come into a proxy, and all three are serving a request at the same time. And there are two ways of doing that. It's implement APIs. It's built on infrastructure level. It requires BGP basically. And the idea is that you have one IP address that you announce from your core router, and then you set the same IP address on each server. And basically, your infrastructure should decide, or basically client should decide what is the closest route to the any given backend or frontend. It's usually used for distance, where distance is sufficient. It still can be used in case you place your abilities on this data center at different firewalls, so it might have limited sense. And for this case, we have a second alternative. It's based on DNS route robin and hierarchy. So what you do here is that for your FTDM, for your DNS, you want to define 3 IP addresses and set each of one on the front end. It was like, it's just DNS route robin, right? So when clients ask for DNS name, it gets from DNS server a result with one IP address. And so basically it wishes randomly one of 3 frontends. However, in case of failure, in case of one of them is down, you will get one set of requests failed. In order to avoid that, you are using Cleura. So basically you make a cluster of HA-proxy using KeepAlive. So basically you make a KeepAlive cluster. And in case one of them is not reachable for some reason, other two, because it's core, other two identifies it and brings IP from first ability zone, second ability zone, and all the rest exit nicely. And with that, we're going to the second part, which is deployment ability zones, because now when we kind of know what design is, it's probably time to make it live. And for that, no surprise, we will be using OpenStack-Ansible. So we use OpenStack-Ansible internally for quite a while. We use it to deploy, configure, and operate all our regions. First time, I guess, we deployed it on Rocky's release, and it was Ubuntu 16.04. Now we are running Xena in all our regions with Ubuntu 20.04. And breaks one smoothly because we run them in the CI, and under we, I mean in community, because OpenStack-Ansible is official OpenStack project, so it's driven by community, and yeah, not only we are using it, but community helps to keep it updated and reliable. We also actively contribute back our findings and web reports and user scenarios. So everything we find, everything we need, we try to bring back, and especially when once the community decides that it's valuable, it's being merged. But it's not only we who decide what's going to be there. We also feel pretty comfortable in running any playbook anytime, so in case we get trouble with our identity cluster, we just run a playbook, and it with a variable provider like upgrade transition queue, and cluster will be restored So it's pretty nice. And since Ansible is supported by design, it's absolutely safe to run this because no independent changes will be made. So it's quite flexible too, and it's quite powerful. So it can deploy inside VC containers, it can deploy environmental. We install services inside virtual labs, and we can also have paths for distro packages. We support Ubuntu, Debian, CentOS, and Rocky Linux since your release. So you can use any of that or actually bits of that. So you can run NetNodes on CentOS and compute nodes on Ubuntu if you want so. In the future, we're also looking into adding ARM support. But we have some troubles with CI testing for that because it takes a bit longer than usual jobs, so it's 10 months. But we hope we will sort this out soon. So, how we are going to configure OpenStack-Ansible to get our deployments? First of all, it's inventory. Eventually, OpenStack-Ansible uses dynamic inventory, and it's quite tricky, I would say. For me, I guess it's the hardest part inside OpenStack-Ansible is to get your inventory configured correctly. Because if it's not, it can do really intended changes. You can still use static inventory, don't use dynamic inventory split at all. It's totally possible, but for some reason I still like dynamic inventory concept. So first of all, we want to define ability zones and groups. It will be quite handy because we will put all our hosts and containers inside these groups, and then we will just define variables for this group parts. So we need something like that structure. Then we will map hosts to ability zone groups. It's done in OpenStack user config, so we are using also YAML anchors to do that, and we feed to AZ host as then. So basically, we have like controller 1 is AZ1 host, controller 2 is AZ2 host, and so on. And basically, if it's running LC containers, then all containers will be also, that are spawned on these controllers will be also part of the Z1 host group. And we also define extra methods if we need them. So, for example, if you are not sharing storage between AZs and AZs have its own storage, then we will need to spawn cinder volumes, stack of cinder volumes basically, inside each ability zone. It's important because cinder volume needs to have access to the storage. So it should be configured accordingly to that and have also network access. And eventually there is code to define cinder volume per ability zone. So now once we're done with inventory, we just configure variables, which is super easy right now. It's a matter of like creating group vars AZ1 all and define AZ name. It's the only variable that you basically need there. And you need some overrides as well. For example, each cinder storage will have this availability zone name. Neutron agent, the DHCP agent. You might notice that there is no Nova, and that's because Nova assigned to ability zone not using config but using aggregates. And OpenStack-Ansible at the moment don't manage aggregates, so basically you will need to create aggregate manually and map aggregate to ability zone. It's all done in one OpenStack command or API call, whatever you wish. In the future, in the nearest future, we are going to add support for managing aggregates as well. We are just thinking a bit on design and how to do this in a better way. But it will be added quite soon, and I guess it will be released for that. Now we need to configure load balancer. So we already discussed that how basically load balancer should proxy requests, but it's time to configure it. So basically, what we want to do, we want to make it agnostic of whether it will be a DNS round robin with VRP or it will be any cast. So for that, we instead of binding HA proxy on specific IP address, we bind it to the interfaces, which is quite neat because any IP that you will assign to this interface, HA proxy will understand that and it will respond. In OpenStack-Ansible, we have like two interfaces for internal, for management purposes, and for public. So you won't, without any extra ACLs, it will just understand this nicely. Yeah, and basically what we need to do is, as I said before, we need to forward all requests to the first backend. So we define instead of list connections, we define balance algorithm to first. And then what we are doing, we are sorting backend nodes in proper order. So we want that current AZ will be first backend in the list, and all the rest will be follow. So we do some Ginger hacking to do that. And for some services like MariaDB and I guess Nova Console that listen only on internal interface, we need to do special hack, which is basically like make them bind on interface instead of address. And I guess the tricky thing is to configure VRP. And it's not tricky, but it's just a lot of overrides that needs to be applied. So I like with HA proxy, we define to bind on specific IP address. And as you might notice, you will need to do this for each AZ because it's just an example for ability zone 1. So you will need to define like several more. And then define VRP instances. So what we are doing here is not only saying on which interface Keep Alive will be listening in and what IP address it will set, but we also want to ensure that Keep Alive that deployed on AZ1 will bring IP address for AZ1 as master, and on other AZs it will be backups. And the same we do with priority. So we want that on current AZ, Keep Alive would have highest weight. And basically, it's example for AZ1 external. You will need to have the same for AZ1 internal, AZ2 external, AZ2 internal, and so on, how many AZs you have. So yeah, it's quite massive configuration, but it's, yeah. Alternatively, you still can use any cast if you want to, but it's what is used by default in OpenStack-Ansible, it's Keep Alive D. And I guess that's all I have for you today. Do you have any questions or something? Yes? For me, between call Ansible and OpenStack-Ansible? Well, I would say it's a matter of preference. For me, I mean, it depends on kind of mindset. I think call Ansible is an amazing tool. One of its big pluses is that it's faster because they build a Docker container only once. However, if you want to go fully bare metal and you don't want to mess up with containers, you cannot do this with Caller. Another thing that, for my opinion, OpenStack-Ansible is more flexible because basically you can do whatever you want. We have overrides for everything. So you can deploy, a simple example, you can have one backend or one control plane running like different version, and you set ACLs for HA proxy to limit traffic only to yourself, to test something out, for example, like local fork of, I don't know, of Nova, for example, with some bug fix backported that can be backported upstream. Because you can override source Git repositories. And the version, and at the same time, Ansible does install only from PyPy. So you don't have this flexibility in Ansible. At the same time, yeah, as I said, it's fast in execution. So, I mean, it's kind of matter of taste and preference, what you like more. Do you like Docker? Do you like Elixir? Do you like bare metal? Do you like deploying with distro packages or whatever? Yes?
Thank you for your presentation. And I want to ask you, are you providing GPU nodes in Cleura?
That is a really good question, yes. At the moment we don't provide it publicly, but we have already deployment that is closed for testing. So it depends on our marketing when we launch it, because we have everything ready. We have 8 GPUs. Yeah, split it a bit, but if you reach our sales, they will provide you with better data, I believe. Okay, then thank you, everyone.